Good job. All right, that's fine. Let's stop this. Let's see. Let's hit done. Come on. That's fine for now. And all right, let's get rid of this. My courses. Where is it? There it is. So let me see. This is 3 o'clock. So this is College Algebra 1 with lab. The 3 p.m. is this one. Allow. What does it do that? I was literally just using this like 2 seconds ago. This one, and come on. Allow. It's actually moving fairly well. I know we kind of had a late start. It's moving a little bit slow, but oh, okay. So we did this one. That's cool. We're gonna go like this. Okay. So before we get started on this, I just want to do an update on like. Now we might have a short session. We'll see. I shouldn't have used it. I shouldn't have got your hopes up. I mean, honestly, you guys can make it whatever like you want anytime because, okay, this is remote online asynchronous, right? So as long as you get your attendance credit, the rest of it is okay. I don't want to sell you short though because you know you pay for this time for us. So I do the best I can to be available. Let me see now. As far as announcements go, sorry for the late start. I had a meeting that ran long. It was a kind of a bizarre case, but we did the best we could to get to the bottom of it. So this is the end of week 3, right? So the biggest piece of information is that exam 1 will become available this upcoming Sunday. It's going to become available this upcoming Sunday, right? I think I scheduled it to become available at 11 a.m., right? And then it'll be available for 7 days. It'll be due the following Sunday at 11:59 p.m., right? So for those 7 days, you can get the max amount of points. You can get up to 100%, unlimited attempts, and the system is set to take your highest score. You can work on it past the due date, but there's a 10% late penalty. So past the due date, the highest you can earn is a 90%. My recommendation is to you want to start the exam as soon as possible. As a courtesy alert, there's 2 things. One was that there are prerequisites for the exam. And then 2 is that it's a prerequisite, and what was the other thing? How's it going? Keys to what? Are you trying to move it? He can't it's not enough space for him to get around it. Are you going to be able to move it? If you give me a few minutes, I can move it. Let me see. So the prerequisites are we need to pass the quizzes from the quizzes for the corresponding weeks, basically for weeks 1, 2, and 3. So I think each quiz has like 5 questions. So we need to get at least 4 out of the 5 correct in order to access the exam. And then also each time you take the exam it should be a different exam, right? Where it's going to be different questions, not shuffled. I mean, completely different questions. But it's still going to be from the same content, right? It can only be, but so different. It's going to be from the same sections, right? So it's still going to draw from the same pool, but it's going to be different questions. So I say that to say, you just want to have some level of confidence going into the exam. And I just wanted to, hey, come here. I'm trying to think. Come here. Come on. Come here. Come on. Come here. Let's go. Thank you. I just wanted you to have a heads up about the prereq. I didn't want the exam to be available, but you can't access it because you haven't started the quizzes, right? The original intent is for class time to be like a study session or office hours or Q&A session. I just fill it with like the lecture and homework just to fill the dead air. So we can at least be working on something together. As usual, if there are questions, just feel free to either unmute yourself or type in the chat. I do check the chat periodically, or if you unmute yourself to just get my attention. With the time that we have remaining, let's take some time and continue. Stop. Let's continue making our way through the homework section. So I think on Monday. Now, my original thought was to go through the lecture, but I feel like a better use of our time is let's continue with some of this homework, right? Because you actually have a copy of the corresponding lecture for this section. It's on my YouTube in the playlist. If you go there, you'll find it for College Algebra 1. You can find a full lecture. So the stuff that I would do live, a copy of it is available, so you can always draw from that. So I feel like a good place to be working is on the homework. So where we left off, this is question number 12. It comes from section 1.3, question 29, and it asks us to find the domain, right? So for something like this, as a reminder, this is a rational function, and the domain for rational functions is in general all reals except any x that makes the denominator 0, right? So we need to find the values of x and make the denominator 0. Let's write this one out. Okay. So come on, please. So let's start by getting a copy of this guy. Man, I'm glad this is just like my personal channel. I'm not doing this for like, you got to be in a quiet distraction. This dog is like losing her mind. I'm like, are you about to bark yourself into the street? Be quiet. Bark you into the street by yourself, where you can be as wild as you want to be. All right, that's a little bit weird. Okay, that's better. So let's take this. We're gonna drop it right here. Let's try to, come on. And let me check something. The 3 p.m. is correct. Okay, I think we're okay. All right. So the domain of something like this is going to be all reals except any x that makes the denominator 0, right? Let's plug this. There we go. So then what we want to do is set the denominator equal to 0 and solve, right? So we're going to say set the denominator. We want to set it equal to 0 and solve. So then we're going to say x squared minus 5x plus 6. We're going to set it equal to 0, right? So then this is a factoring, right? We got a trinomial, 3 terms that are being added and subtracted. So maybe we can jump straight to this form for factoring a trinomial. We got x and x. This second plus tells us our signs are the same. We don't know if they're both positive or both negative. We just know that they're both the same. This first sign tells us the larger number is negative, right? So if they're the same and the larger number negative, that means they're both negative. We're looking for 2 numbers that multiply to give us 6 and add to give us -5. And then from there, I think we got it. 3 and 2. Come here. Come on. Come here. All right. As long as she's quiet. Right? So -3 times -2 is +6. -3 plus -2 is -5, right? So then from here, we want to use what's called the 0 factor property. When we have 2 or more things that multiply to give us 0, we want to use what's called the 0 factor property. When you have 2 or more things that multiply to give us 0, we basically set each thing to 0 and solve. So we're going to say x minus 3, we set it to 0. Another result is going to be x minus x minus 2 and set it equal to 0. If we solve each equation, we get x equals 3. Thank you. We get, oh, good job. X equals 3 and x equals 2, right? So what we're saying is that when x is 3 or x is 2, it makes a 0 in the denominator. So these are two numbers that we want to throw out. So for the domain of a rational function being all reals except these two numbers, there it is. Okay. So say this is the x-axis. Say here's our 2 and here's our 3. Right? And we want to throw these two guys out. So we want to exclude the 2 and we want to exclude the 3. So if we plot 2 and 3 on a number line, what it does, it breaks the number line up into 3 regions. We have this left region, this center region, and this right region, right? If we want to write this in interval notation, how do we capture the far left? If we're going way, way, way to the left forever, how do we capture that? What is that called? Right. So the far left is called what? Negative infinity. Right. So then as we trace it from the left to the right, what's our first checkpoint? Okay. Let me check something really quickly. Okay, so we do have people here. Let me get the student. See you in the next class? No, he's here. Okay, good. Cool. At least we got our attendance, so that's good to go. I think the chat looks good. Okay. So the far left is infinity. Infinity always gets parentheses, right? Because we do not want to include the 2, all right, it's going to get a parentheses. Then we're going to say union. To capture all the numbers between 2 and 3, we want to go from 2 to 3. But because we do not want to include the 2 and 3, they both get parentheses. Another union. And then we want to capture all the numbers to the right of 3. So we want to go from 3 to infinity. Infinity always gets a parentheses. Because we do not want to include the 3, we get a parentheses. All right. So to capture, so again, for this example, if we want to capture all numbers except 2 and 3 and write our final result in interval notation, it's going to look like this, right? So I think we have a poll, right? Let me hop back over here. So it says choose the correct domain below, right? So what I'd like to do, what we were able to do earlier, if I can get it to behave. Let me see if I go here and right here, there's a poll. Can I just relaunch the poll? Relaunch. Launch. Okay. So there's a poll that's available on Zoom, right? Can you tell me the correct result? If I can get it to show. There it is. So is the correct result A, B, C, or D? Right? So there is a poll available right now on Zoom. Is the correct result A, B, C, or D? You guys there? I don't think you're there. Nobody's there? Okay. Okay, well, I will, I'm just gonna talk then, and I'm just gonna power through it. I think we got A, right? So I'm just gonna go with A, check the result. Okay, somebody's there. Somebody's alive. Okay, I was like, are these guys alive? It's like, uh-oh, we're gonna try it on another one. You might be able, let me refresh the poll, relaunch it, and we'll leave it there. How do I restart it? Relaunch. Because we'll save it for another. Okay, that's fine. Okay, we can actually use the poll on this one. Okay, Okay, so A is yes and B is no, right? I think the poll is available. Where'd it go? Come on. There it is. And next we'll go like this. All right. Okay, so we'll let A be yes and B be no, if we can get this to work. Right. And it says use the vertical line test to determine if the graph is a function, right? So then if we have this graph here, can we like zoom in some? Maybe if I go like this, might look a little bit better. Oh, it's not gonna let me zoom in anymore. Okay. We go like this. All right. So does this, say we have these collection of points, do these points pass or fail the vertical line test? Let me see. The question says, is the graph a function? Yes or no? Okay. If it fails the vertical line test, then it would be B. It's not a function. If it passes the vertical line test, it would be A. It is a function. So does this pass the vertical line test for A or fail the vertical line test for B? Does it pass for A or fail? Right. So I think we kind of said something to the effect of the vertical line test. Failing the vertical line test means you can draw a vertical line and it'll cross the graph more than once, right? So is it possible to draw a vertical line and it touch the graph more than once? All right. So is this graph a function? We're going to say yes, it's a function, which is A, because it passes the vertical line test, right? Let's just try another one. Use the vertical line test to determine if y is a function of x, right? So does this pass the vertical line test or fail? I think we could still use the same poll that's already there, where A would be, yes, this is a function of x, or B is, this is not a function of x, right? So I think the graph passes the vertical line test. Man, okay, there we go, right? Part A, right? Anybody else? Any takers for B? Okay, so we got at least one, and that's a good start. That's a great place to start. Y is a function of x, right? So let's go with it. We're gonna check. If any, again, as usual, if anything is not clear, you have to get my attention. Okay, what about this one? Now, I want to say that you should be able to update the poll. This one says to use the vertical line test. Let me zoom in some. I just don't like the way that looks. Hopefully that's not zoomed in too much. There it is. You always have to, it's a little bit temperamental, but use the vertical line test to determine whether the given graph is a function, is the graph of a function. So A would be yes and B would be no. Is the graph of a function? Is it A yes or B no? All right. Is this let me relaunch the poll, because I think that's from the previous one. Relaunch. Launch. Okay. So is this the graph of a function? Is it A yes or B no? Is this the graph of a function? In other words, does this pass the vertical line test? A yes or B no? Right. So in order for this to be a function, it has to pass the vertical line test. All right. I think we got at least one taker. All right. All right. Okay. So notice we can draw a vertical line. It touches the graph more than once. So then it's not a function. So then is this A or B? This would be B. All right. So let's just go with B. Awesome sauce. Let's go to the next question. Right. And this is anonymous, right? It doesn't, it's anonymous. We got a 20% participation. People are just dropping. That's all good. It's all good. Let's reload. I'm going to relaunch this. So we can just start a fresh one, launch it. Awesome sauce. Okay. Answer the questions about the following function. Is this point on the graph? Okay. I wonder if I can see who's submitting. We don't have that many people. So for part A, right? Is this a point on the graph? We have f of x equals 3x squared minus x minus 2. All right. I'm going to let you guys do this one. And we'll do it part by part. So is this one, I'll give you like a couple of minutes. We don't have that much time. Hey Siri, set a timer for 2 minutes.
2 minutes, counting down.
So we're just focused on part A. Is the point -1, 2 on the graph, right? You can either just guess, it's either A or B, with A being yes and B being no. Or can somebody come on the call and explain to us how would we approach part A? How would we approach this part A? All right. Let's give it a couple of minutes. So we have this function, f of x equals 3x squared minus x minus 2. And then is this point on the graph, right? So basically it's saying when x is -1, is the corresponding y 2? So if we plug in x equals -1, let's see what happens, right? So -1 times itself is a +1. 1 times 3 is 3. 3 minus -1 is really 3 plus 1, which is 4. 4 minus 2 is 2. So is the point -1, 2 on the graph? We would say yes, right? So we're going to go with yes on that one. Okay. Let's go on to the next part. So if x is 2, then what's the corresponding y? All right. So instead of doing it by hand, I would like to pull up my trusty dusty rusty. Let me see if I can get it to work. There it is. Let's do a demo on our graphing calculator. All right. Now I think we did something like this last time, but let's do it here. In the upper left-hand corner, I'm going to go to my y equals, and I'm going to type in what we have: 3x squared minus x minus 2. Okay. So I'm going to quit and go back to the home page. Now, when x is 2, what's f of x? So I want to, hey Siri. So I want to call on the function that I just typed in. On the right-hand side of the calculator, there's a button that says clear.
Sorry, I don't have a phone number for London Bergsteiner. Who would you like to call?
Cancel.
Okay, I won't.
To the left of the button clear is a button that says VARS. It stands for variables. I'm going to click on that. To the right, it says Y variables. And then number 1 is function. And then number 1 again to call on the function that we just typed. And let's just check it real quick. For part A, we said when x was -1, we got a result of 2. I'm going to hit second enter to call that on again. Now we want to see, okay, when x is 2, what result did we get? We got 8. All right. So when x is 2, it says type an integer. We got 8. So let me go like this. Come on. Turn that off. Type an integer, a simplified fraction. We got 8. Okay. List a point on the graph. So that would be the point 2, 8. 2, 8. Type an ordered pair using integers or fractions. Okay. And then part C, if y is -2, what's the corresponding x? So now they're giving us y equal to -2, and they're asking us to work backwards, right? So they want us to solve for x. So we got 3x squared minus x minus 2. Let's get a copy of the original. Let's get a copy of the original and work backwards, right? So I'm going to take a screenshot. That one. We'll go to about here. Cut it off about there. That looks good. Now let's take this. We're gonna drop it right here. All right. And let's change the crop a little bit. So we're just about out of time. We'll do the best we can. We might have time for one more after this one. It just depends on how long it takes us. Okay, so I think we were working on part C. So it says if our y is -2, then what's the corresponding x, right? So let's plug that in. We're working on part C. We have 3x squared minus x minus 2. And we're letting y be negative 2. And we want to solve. So we can start by setting it to 0, add the 2 on both sides. So then we'll get 3x squared minus x equals 0. Okay. And then we can factor. So I think they both have x on the left. So we'll get x times 3x minus 1 equals 0. Here we use the 0 factor property. When 2 or more things multiply to give us 0, we set each thing to 0 and solve. So then we get that x equals 0 or 3x minus 1 equals 0. Add 1 to both sides, we get 3x equals 1. Divide both sides by 3, x equals a third. Okay. So then now we need to go back and see what do these results mean in the context of the original question. So let's see. If y equals negative 2, what is x? What point or points are on the graph? Okay. So we got 0 or a third, right? We got 0 or a third. Come on. Type an integer, use commas to separate answers as needed. I think we got 0. Zero 1/3. Okay. 0, comma 1/3. So let's go for one more. We're almost done. We haven't finished this question. This question will probably be it. List the x-intercepts. I really would rather skip that one. I personally like to do the y-intercept first, but we can't get to that one. It says, oh, the points. Wait, we got to list the points when y is negative 2. So then the corresponding ordered pairs. I think we got 0, comma negative 2 parentheses, and then the other one was a third. Yep. Comma negative 2. Okay. I think these are the 2 order pairs. Okay. And then for the x-intercepts, we set wait a minute, domain, right? So this shape is going to be a parabola. It's a polynomial, right? So the domain of all polynomials is all reals. So this is going to be a U-shaped curve. Every x is accounted for on the x-axis. For each x on the x-axis, you can find a y. So the domain is going to be all reals, negative infinity to infinity. Parentheses, negative INF to INF. All right. Okay. X-intercepts, we set y to 0 and solve. Okay, let's work on that one. So if we start this guy, we want to set this equal to 0 and solve. Let me copy. We're working on part E. Let's try to wrap this up. So then part E, thank you. Paste. We want to say set this equal to 0. So then we want to factor this. Now, my recommendation, we have to use a technique called the AC method of factoring. In the past, you might be used to 2 numbers that multiply to give you negative 2 or negative 1, but that only counts when its leading coefficient is in a 1. So we had to say 3 times this to give us negative 6. We're looking for 2 numbers that multiply to give us negative 6 that add to give us negative 1, right? So let's just go through the list. These add up to 5, so these are not the 2 numbers we're looking for. We can do 2 and 3. These are close, but this adds up to positive 1. We want negative 1, so we're just going to switch the signs. So then these are the two numbers that we're looking for, right? So what I personally, from this point, once we find those two numbers, I like to use what's called the box method. As soon as they'll show me to factor something like this. So if we go like this, right? This is a box technique. In the upper left-hand corner goes the leading term, which is this 3x squared. The bottom right is the constant, which is the -2. And then on the other diagonal, we use the two numbers that we found, right? So I think we got, and we're rewriting that -x using the -3x with 2x, okay? So then, let's start here. What can we factor out of the two on top? We can factor out, they both have 3x, right? What do the two on bottom have in common? We can factor out a 2, a +2. Okay. What can we factor out of the two on the left? They both have x, so we're going to factor out an x. And what can we factor out of the two on the right? It looks like it's -1. All right. So then if we put all that information together, the claim is the following. Let me copy this. I see the time. Let me copy, paste. The claim is that that line factors into 3x plus 2 times x minus 1. And you can check by foiling. Just because we're out of time, I'm just going to go with it. So if this is correct, then we use the zero factor property. That means 3x plus 2 equals 0, or x minus 1 equals 0. Subtract and divide. -2 by 3, or x equals 1. All right, so we got these two results. So these are x-intercepts that we got, -2/3 and 1. Type in integer. So we got -2/3, 2 by 3, comma 1. Okay. And then for the y-intercept, so for the y-intercept, you said x is 0. If you said x is 0, you should quickly be able to see those first terms go to 0. And that leaves us with y equals -2. -2. Okay. And on that note, we are officially out of time. Are there any burning questions before we go our separate ways? Any burning questions? Okay. So closing remarks or announcements. Again, just as a reminder, we have exam 1 that'll become available this Sunday. It's due the following Sunday at 11:59 p.m. It'll be available at 11:11 a.m. Unlimited attempts. There's a prerequisite, so you want to be sure that you go ahead, try to pass quizzes for weeks 1, 2, and 3 as soon as possible. So that way, when the exam becomes available, you can get started. You don't want the exam to be available, but you can't access it because you haven't done the prerequisites, right? Okay, I think that's the pertinent information. If there aren't any burning questions, we're going to end the session here. And from one beautiful mind to another, enjoy the rest of your weekend. All right, guys, take care. Peace. Right, all right. Like this.